Metal G or Betelgeuse, it's a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It's very unstable, about to explode. Investigating the mysterious Betelgeuse to its core, new research has uncovered phenomena that contradict our present knowledge of star activity. In addition to its gigantic size and impending supernova potential, scientists have been perplexed by Betelgeuse's erratic dimming patterns. This is an example of unusual stellar behavior, as well as a star approaching the conclusion of its life cycle. Current astrophysical models fail to adequately describe Betelgeuse's complicated internal dynamics, which are indicated by its unevenly pulsating surface. In contrast to normal red supergiants, a nebula of dust and gas is forming around Betelgeuse as a result of its incredible rate of material shedding. According to researchers, this stellar mass loss is significantly more violent and unpredictable than what is predicted by theoretical models for stars in its class. The results have far-reaching consequences, suggesting that red supergiant development is driven by unknown mechanisms. On top of that, strange magnetic activity on Betelgeuse's surface has been picked up by recent observations. This new field of inquiry could be affected by this activity, which could be affecting the star's mass ejection patterns and variability. Both the observed and predicted magnetic fields are more complexly arranged, casting doubt on the standard model of star magnetism. These new findings have scientists rethinking Betelgeuse's ultimate destiny. Although a supernova explosion is expected, the exact moment and type of this catastrophe are currently the topic of heated debate. The peculiarities of Betelgeuse's behavior suggest that it may not undergo a supernova explosion in the manner that is currently anticipated for red supergiants. Some have speculated that Betelgeuse's quirks may have been influenced by an outside force, such as a planet or companion star. This has added another layer of mystery to the situation. One possible explanation for Betelgeuse's sporadic dimming and mass loss could be the gravitational influence of a neighboring celestial body, which would deform its outer layers. In light of these new facts, Betelgeuse should be seen as a lighthouse for rethinking ideas about stellar evolution, not only a case study in stellar life cycles. Understanding the many outcomes of stellar development, especially in the last stages of life for big stars, may be facilitated by the star's distinctive features. Beyond being an astronomical spectacle, Betelgeuse's imminent supernova is a watershed moment that might reshape astrophysical theory. An extraordinary chance to examine the demise of a huge star in unparalleled detail could be presented by the energy emitted by such a supernova, which could be observed from Earth. Among the less discussed consequences of Betelgeuse's supernova is its influence on the local cosmic environment. Nearby molecular clouds may be stimulated to produce new stars by the shock waves and expelled material, with the potential to give light on the stellar lifespan. This process, called triggered star formation, could give rise to a new generation of stars. Important information on supernova explosion physics could be gleaned from Betelgeuse's light curve. Live observation of the explosion stages could either confirm or refute current predictions, particularly those related to supernova nucleosynthesis, the production of heavy elements like uranium and gold. This phenomenon has the potential to profoundly alter our knowledge of the distribution of these elements in the cosmos, which are essential to the makeup of planets and life. Possible detection of neutrinos and gravitational waves from the supernova is another promising area. The characteristics of dense matter and the dynamics of supernova cores could be better understood with the help of such discoveries, which could pave the way for new directions in multi-messenger astronomy. Also, the compact object that was left behind after the supernova could be revealed to be a black hole or a neutron star. In its aftermath, our knowledge of stellar remnants and the final phases of stellar evolution would be greatly affected by this result. Supernova Betelgeuse may have far-reaching effects on the interstellar medium, changing its chemistry and dynamics while adding heavier atoms to it in the development of galaxies and planet systems. This enrichment process is pivotal. Finally, the effect of a Betelgeuse supernova on Earth's ecosystem is an intriguing but hypothetical option to think about. While the star isn't close enough to cause any immediate danger, the brightened sky could have an impact on animals that sleep during the day and could have a domino effect on other ecosystems. With all these things at stake, the final supernova of Betelgeuse is more than just a spectacular sight, it is a paradigm shift with far-reaching consequences for the fields of astronomy and astrophysics. Thanks to its unparalleled sensitivity and resolution, the James Webb Telescope has revealed previously unknown complexities in Betelgeuse's behavior. Among the most shocking findings is the identification of finer features in the star's outer layers that had not been observed before. The observation showed that the star's breathing is caused by a network of big convection cells that move heat from the core to the surface. The complexity of this pulsation is beyond anything we have seen before. Its magnitude and brightness changes test our assumptions about star dynamics. With the James Webb's near-infrared capabilities, scientists have been able to see the dust production processes around Betelgeuse unfold in real time. Stars' roles in the cosmic dust cycle, which is necessary for planet formation and life as we know it, can be better understood through this process. A red supergiant's mass loss processes can be better understood thanks to the telescope's observation of material ejection from Betelgeuse's surface, which captured the birth of this stellar dust. Furthermore, Betelgeuse's magnetic fields yielded an unexpected finding. The James Webb Telescope has found intricate structures in the magnetic fields of these enormous stars, disproving earlier assumptions that their environs were rather basic. Based on these results, the star's magnetic field is probably affecting its pulsation behavior and is crucial to its mass loss process. Most intriguingly, Betelgeuse's expelled material shows indications of possible chemical complexity. According to James Webb, it was not thought that molecules, and maybe even organic compounds, could exist in the hostile environment surrounding a dying star. The nature of the molecules that can be formed in space and the chemistry that happens around supernova are both brought up by this new finding. Better predictions of when Betelgeuse would go supernova have been made possible by the more exact observations of its size and temperature that the telescope has supplied. Models that attempt to foretell the lifespan of large stars rely heavily on these measurements. But that's not all Betelgeuse has to hide. After this first perplexing layer, there will be even more to peel back upon further inspection. What did we discover beneath its throbbing surface? We invite you to accompany us as we unveil a cosmos that surpasses our wildest dreams. Delving into the most recent observations of Betelgeuse made by the James Webb Telescope brings attention to the star's mysterious character and ushers in a new age of cosmic exploration where every new discovery raises more questions than it answers. Among the giants of the universe, Betelgeuse stands out as an unmatched observational target for amateur and professional astronomers. At about 642 light-years from Earth, this star, which marks the shoulder of Orion, can be seen clearly even without telescopes. It is a bright, clearly reddish star. Among the stars, the fact that it is pulsating, which is not easy to see with the human eye, further complicates matters when studying Betelgeuse because it is not simply expanding and contracting in a regular rhythm. We do not have a good model of its pulsation behavior because it is so irregular and complicated. The one certain thing is that it is on the brink of becoming a supernova. When Betelgeuse explodes, it will be a sight to see. Astronomers predict that the explosion could be so bright that it would be visible during the day. We are not sure when it will explode, it could be tomorrow or in 100,000 years. What we do know is that when it explodes, it will be the most remarkable astronomical event in centuries. Even though the closest supernova to Earth occurred in 1604, it was dim and hardly visible to the naked eye. Betelgeuse's explosion, on the other hand, will be visible to anyone on Earth. While this cataclysmic event will be a scientific milestone, it may also have a lasting impact on our planet. Although Betelgeuse is located far enough away that it will not pose a threat to Earth when it explodes, the explosion itself could have an impact on Earth's atmosphere. It could affect the Earth's climate and even its weather patterns. The star's explosion could have an impact on the Earth's magnetic field, causing it to become disrupted or altered in some way. This could have serious consequences for the Earth's climate and weather patterns. Additionally, the explosion could send a burst of radiation toward Earth, which could have a number of effects. It could disrupt satellites and other technology in orbit around the Earth. It could also cause changes in the Earth's atmosphere, leading to changes in weather patterns and climate. While the exact effects of Betelgeuse's explosion on Earth are uncertain, one thing is clear: it will be a remarkable event that will have lasting effects on our planet.